Hello friends, in today's session we are going to see some more related topics to our chapter. Okay, so we will continue further with the same topic. Get item selectable method can be used to obtain a reference to the item selectable object that generated the event. Okay, so for event get item selectable will give you the reference to item selectable object. So it will return you item selectable object, get item selectable. List and choices are examples of user interface elements that implement the item selectable interface. Okay. Okay. Get state change method returns the state change that is selected or deselected for the event. Okay. So selected as well as deselected will be returned by get state change. It is shown like integer get state changed. Okay. Next is key event class. Key event is generated when keyboard input occurs. When any user enters through a keyboard, this key event will be generated. There are three types of key events: key press, key release, and key type. Okay. So these are three constants. First two events are generated when any key is pressed or released. Okay. When you press the key, it's key pressed. When you release it, key released. As simple as that. Last event occurs when character is generated. Okay. So whenever you are entering a key and that is creating a character, it can be A to Z character, alphabetical character, it can be numerical character 1 to 10, or it can be any special character. Okay. So any type of character, if it is generated, it will generate the event key type. Not all key presses result in character. Okay, pressing shift does not create any particular character. There are many integer constants that are defined by key event. Okay, so there are many other integer constants, those we will see now. vk underscore 0 through vk underscore 9 and vk underscore a through vk underscore z define the ASCII equivalents of the numbers and letters. Here are some others. Okay, vk underscore alt, vk underscore cancel, control, down, enter, escape, left, page down, page up, right, shift, and up. These all characters, these all keys are present in our keyboard of our laptop or our desktop. But these particular keys does not generate any type of character. Okay, so these are the special keys, and for these special keys, simple separate integer constants are created. Okay, for example, for alt key, constant is created vk underscore alt. For page down, vk underscore page down constant is created because those are special keys. Those do not generate any particular characters. vk constant specifies virtual key codes and are independent of any modifiers, control, shift, and alt. Okay. So vk is equal to virtual key codes and independent of control, shift, or alt modifiers. Okay. Key event is a subclass of input event. Here is one of its constructors. Component source, integer type, long when, integer modifiers, integer code, and character ch. Okay. So input event subclass is key event and its constructor is given over here. Source the reference to the component that generated the event. Type of the event is given by type. System time at which key was pressed. Okay, the generated system type set system type is passed in when. The modifiers argument indicate which modifiers were pressed when this key event occurred. Okay, so modifiers are control, shift, or alt. Virtual key code such as vk underscore up, vk underscore a, and so forth is passed in code. Okay, so any virtual key code we have seen right now, these type of codes or integer constants are passed in code. The character equivalent if one exists is passed in character. Okay. If no valid character exists, then ch contains character undefined. If the particular key that generated the key event is unable to create a character from the particular character, it contains character undefined as a character ch. Key typed events code will contain vk undefined. Okay. The key event class defines several other methods, but probably the most commonly used are getKeyCharacter, those return character, and which returns the character, and keyCode, which returns the key code in integer format. So there are two methods given by key event class. First is getKeyCharacter, and it returns the character. Second is getKeyCode. It will return you the integer code. For no valid character is available, then getKeyCharacter returns character undefined, and when a key type event occurs, getKeyCode returns UK, VK undefined. Okay. Next is mouse event class. There are 8 types of mouse events. Mouse event class defines the following integer constants that can be used to identify them. Okay. So there are 8 types of mouse event occurs. Mouse click, if user clicks the mouse. Mouse drag, user drag the mouse. Mouse entered as a component. Mouse exited from a component. Mouse moved, mouse was moved. Mouse pressed, the mouse was pressed. Mouse released, the mouse was released. Mouse wheel, the mouse wheel was moved. Mouse event is a subclass of input event. Okay. So one of its constructor is mouse event component source, integer type, long when, integer modifiers, x, y, clicks, boolean, triggers, pop-up. Source is a reference to the component that generated the event. Type of the event is given by type. The system type at which the mouse event occurred is passed in when. The modifiers argument indicates which modifiers were pressed when a mouse event occurred. Okay, so modifiers are Control Alt and Shift. Okay, so these are the modifiers. Coordinates of the mouse, at which position on the screen the mouse was clicked, are passed in x coordinate and y coordinate. Click count is passed in click, how much time it is clicked. If it is clicked once, it will be having the 1 as argument. If it is mouse is clicked 2 times, it will be entered 2 times, and so on. Next very important thing is triggers pop-up flag. This indicates if this event causes a pop-up menu to appear on this platform. Okay. This, if it is true, it tells that this event causes a pop-up menu. Like we right click on any particular folder. So for that particular, the pop-up occurs like you can copy that folder, you can cut that folder, you can view the properties of that folder, and you can have the size of that folder, particular folder. You can rename that folder. So list of items are clicked or are displayed on the screen as a pop-up menu when you right click on that particular folder. And when you double click on that particular folder, this folder will be open. So triggers pop-up flag will be returning true if any particular menu is appearing after you are clicking on that particular folder as a right click, right? This is the just example. This is for the sake of example only. Two commonly used methods are getX and getY. Those will return X and Y coordinates. These return X and Y coordinates of the mouse within the component when the event occurred. Okay. In that particular component, that component can be anything. It can be image, it can be button. On screen, in that particular component, the X and Y coordinates will be given. Okay. Their forms are integer getX and integer getY. You can use the getPoint method to obtain the coordinates of the mouse. It will return you point, getPoint. Okay. It returns a point object that contains the X and Y coordinates in its integer members, X and Y. Translate point method changes the location of the event. Okay. So uh, where the point where if you have clicked on one button at particular x and y coordinate like 10 10, okay, when you are using the translate point, you can reposition that x and y coordinate at the new place. You can place them at 100 100 if suppose void translate point x and y. So previous coordinates are changed or overwritten by this new coordinate. You clicked and at that particular button at x coordinate 10 and y coordinate 10. But you are translating that point to another point that is 100 into 100. Okay. The arguments are x, y are added to the coordinates of the events. The get click count method obtains the number of mouse clicks for this event. Okay. So integer get click count. So how many times the click mouse was clicked? Is pop-up trigger method test if this event causes a pop-up to menu appear on this pop-up menu to appear on this platform. Boolean is pop-up trigger, it will return true or false. Also available get button method, it returns a value that represents the button that caused the event. Okay, which button that caused the particular mouse click event. The return value will be one of these constant for most cases defined by mouse events. No button, button 1, button 2, button 3. Okay. No button that give you that no button was pressed or released. Also available are three methods that obtain the coordinates of the mouse relative to the screen rather than the component. Get location on screen. Okay. So location can be alternate for the component in GUI, and location can be alternate for the position on the screen, that is complete laptop screen or complete desktop screen. Okay, so these three methods will give you location on relative to your complete screen rather than the component. Point get location on screen, integer get x on screen, integer get y on screen. Okay, the get location on screen method returns a point object that contains both the x and y coordinates. Okay, if it will give you the point class object that give you x and y coordinate. Other two method return the indicated coordinate. Okay, so if it get x, it will return you x coordinate, and if it get y, it will give you integer get y coordinate. The mouse wheel event class. This class encapsulates a mouse wheel event. It is a subclass of mouse event. Not all mice have wheels. Okay. If a mouse has wheel, it is typically located between left and right buttons. Okay. So wheel between two right left buttons that is used generally to scroll the page. Okay. When you scroll that wheel, your cursor on the screen will scroll. Okay. So not all particular mouse will have not all particular mice will have wheels. So mouse wheel event is applicable if and only if your mouse has wheel. Okay, mouse wheels are used for scrolling. Mouse wheel event defines these two integer constants. Wheel block scroll, a page up or page down scroll event occurs. Wheel unit scroll, a line up or line down scroll event occurs. Okay, so either you are paging up or paging down, or you are lining up or lining down. Here is one of the constructors. Mouse wheel event component source integer type long when integer modifies x y coordinates, clicks boolean triggers pop up integer scroll how integer amount integer count. Okay, source is a reference to the object that generated the event. Type is given by type. System time at which is given in when. The modifiers indicates which modifiers were pressed when the event was occurred. Then coordinates are given in x, y. Number of clicks is given in clicks. All the parameters are same as the mouse event. Only few are added over here. Triggers pop-up indicates if the event causes a pop-up menu to appear on this platform. Scroll how must be either wheel unit scroll or wheel block scroll. Constants we have right now. See the number of unit to scroll is passed in amount. Okay, so if you are scrolling 5 by 5, the unit will be 5. If you are scrolling one by one, unit will be 1 and so on. Count parameter indicates number of rotational unit that the wheel move. Okay. So amount will have number of units to scroll, and the count will give you number of rotational units that the wheel move. Okay. So if the amount is suppose 2, okay, and you are scrolling 2 by 2, and your your count parameter is 5. So you are moved 5 times, for example. So 2 unit 5 times, that is 2, 2, 2, 2, 2, 5 times. Okay, so 10 units were moved and your rotational unit was 5. Okay, so you moved 5 times either up or down rotationally, having the unit as a amount. That amount can be anything. Mouse wheel event defines method that will give you access to the particular wheel event. Okay. Wheel rotation. To obtain the rotational unit, call get wheel rotation. It returns the number of rotational units. If the value is positive, the wheel moved counterclockwise. Okay. Counterclockwise. If the value is negative, wheel was moved clockwise. Okay. So you have to remember this. If the value number of rotational units are returned by get wheel rotation, first thing you have to remember, get wheel rotation method. It returns the number of rotational unit. 5 times it was rotated, 10 times it was rotated. If it is plus, it is wheel was moved counterclockwise and or anti-clockwise if suppose, and if value is negative, wheel was moved clockwise. Okay. Also available is a method called get precise wheel rotation, which supports high resolution wheels. Okay. It works like get wheel rotation but returns a double value at a precise format. In a precise format, it returns the value. Okay. To obtain the type of scroll, get scroll type. It returns either wheel unit scroll or wheel block scroll. If the scroll is wheel unit scroll, you can obtain the number of units to scroll by calling get scroll amount. Okay. How much amount it was having as a unit? It was 2, or it was 10, or it was 5, so on. It is shown here, integer get scroll amount. This is a method. Next, text event class. Instances of this class, text event class, describe the text event. These are generated by text field and text areas when characters are entered by user or any type of program. This defines integer constant text value changed. Only one constant you have to remember. Anything regarding the text has been entered or deleted, it will generate a text value change constant. Update the constant value. Okay. And it is related directly to text field and text areas when characters are entered by user or any particular type of program. One constructor text event object source integer type. Source is a reference to the object that generated this event. Type of the event is specified by type. Text event object does not include the characters currently in the text component that generated the event. Okay. So whatever is there inside the text component right now, already written, that do not generate any text event. When you enter or change or modify the text value in the text field or text area, then only this event will be generated. You have to remember this. Okay. If suppose you are creating a text field and you are having the default value entered, like my name is Suvarna. Okay. But I have to add my complete name, like my name is Mrs. Suvarna Sachin Barsode. So I have to edit that text. Whenever I'm editing that text, then only the text event will be generated because I am modifying that particular text. The default text value I am particularly giving before entering any new value, this will not change or this will not generate any type of text event. Your program you must use other methods associated with the text component to retrieve that particular information. Okay. So there are other methods to fetch the default value already entered in the text field before running the program. This operation differs from the other event object discussed in this section. Think of a text event notification as the signal to a listener that it should retrieve information from a specific text component. Okay, signal to a listener. Okay, so you are giving a signal to a particular listener that retrieve whatever is written currently in the text component. This is not directly related to any type of text event. Okay, the window event class. There are 10 types of window events. Okay, so this defines integer constants that can be used to identify them. Constants and their meanings are window activated, window was activated, window closed, window has been closed, window closing, the user requested that the window be closed, window deactivated, window was deactivated, window de-iconified, window was de-iconified, window gain focus, the window gain input focus, window iconified, window was iconified, window lost focus, the window lost input focus, window open, the window was open, window state change, the state of window was changed. Okay, so there are 10 types of commonly window events. Okay, so it's a subclass of component event and it has several constructors. First is window event, window source, integer type. Source is a reference to the object as usual that generated this particular event, and type of the event is given by type. So more constructors are window event, window source, type, window other, window event, window source, type, integer from state, integer to state, window event, window source, integer type, window other, integer from state, and integer to state. So in the first format, window other window object is given. In the second format, only from state and to state are given in constant as a constant integer format. And third one is having both the values from first constructor as well as second constructor, window other as well as from state to state. Other specifies the opposite window when a focus or activation event occurs. Okay, the other specifies opposite window when a focus or activation event occurs. One has gain focus and other is lost focus at the same time. The from state specifies the prior state of the window and to state specifies the new state that the window will have when the window's state change occurs. Okay. Commonly used method in this class is get window. In general method get window. It returns the window object that generated the event and its format is window get window. Window event also defines method that return the opposite window. Window get opposite window. Previous window state integer get old state and the current window state as a get new state. Both returns integer values. Okay. Sources of events. Okay. Next table will give you some of the user interface components that can generate the event. Okay. User interface component. It can be button. It can be text field or anything. In addition to the graphical user interface elements, any class derived from a component like a frame can also generate an event. You can receive a key and mouse event from an instance of a frame. Okay. So component subclasses as well as component, any class derived from component like a frame can generate event. These things you have to remember. We will be handling only mouse and keyboard events, but subsequent chapters we will be handling event from variety of sources. Okay. So event source examples: button generate activation action event when the button is pressed. Checkbox generates item events when the checkbox is selected or deselected. Choice generate item events when the choice is changed. List generates action event when an item is double clicked. Generates item events when an item is selected or deselected. Menu item generate action event when a menu item is selected. Generates item events when a checkable menu item is selected or deselected. Scroll bar generates adjustment events when a scroll bar is manipulated. Text component generate text events when the user enters a character. Window generates window events when a window is activated, closed, deactivated, de-iconified, iconified, open or quit. Okay. Next, event listener interfaces. As explained, the delegation event model has two parts, sources and listeners. Okay. One is source that generate the event and other is listener, whoever is registered with the source, who is interested to have to listen the events and to modify or to handle that particular event will be the listener. So one is source, generator, and handler is listener. As it relates to this chapter, listeners are created by implementing one or more interfaces defined by java.awt.event package. Okay, so how we create a listener? We have to implement one or more interfaces. Okay, so which are the event listener interfaces that will be able to create a class that will act as a listener? Okay, so if you are creating one source that is generating the event, you should also create one more class that should handle that particular event, right? So how that class will be the listener? If that class you want to be listener, you will implement some interfaces from java.awt.event package. When you will implement those interfaces, you will have to implement the methods from that interfaces, and then your class will act like a listener. When an event occurs, the event source invokes the appropriate method defined by the listener and provides an event object as a argument. Okay, what source does? Event source invokes the appropriate method, accurate method defined by the listener. So it will call the method from the listener class and provides the event object as an argument. Okay, so it will call the listener, pass the particular argument, and tell the listener that handle this event. Like key is pressed, do something on this. Text area has been changed, do something on this. Mouse has been clicked, do something on this. Table 25.3 lists several commonly used listener interfaces and provides brief description of the methods that they define. So how many listener interfaces are and methods given by those, we will see them. The following sections examine the specific methods that are contained in each interface. Okay, so commonly used event listener interfaces. Action listener defines one method to receive action event. Adjustment listener defines one method to receive adjustment events. Component listener defines four methods to recognize when a component is hidden, moved, resized, or shown. Container listener defines two methods to recognize when a component is added to or removed from the container. Focus listener defines two methods to recognize when a component gains or loses keyboard focus. Then item listener defines one method to recognize when the state of item changes. Key listener defines three methods to recognize when a key is pressed, released, or typed. Mouse listener defines five methods to recognize when the mouse is clicked, enters a component, exits a component, is pressed, or is released. Mouse motion listener defines two methods to recognize when the mouse is dragged or moved. Mouse wheel listener defines one method to recognize when the mouse wheel is moved. Text listener defines one method to recognize when a text value is changed. Window focus listener defines two methods to recognize when a window gains or loses input focus. Window listener defines seven methods to recognize when a window is activated, closed, deactivated, iconified, open, or quit. Okay. Action listener interface. Interface defines the action performed method that is invoked when an action event occurs. This method is invoked automatically, but from whom it is invoked? From the source. When you are creating any interface, that will be when you are generating when you are performing any action, your source will generate an event and your source will pass a parameter as a here as action event object. Okay, void action perform action event A. So this will be having the object which action was actually performed. Adjustment listener interface. This interface defines adjustment value change that is invoked when adjustment event occurs. Void adjustment value change adjustment event A. Component listener interface. This defines four methods that are invoked when a component is resized, moved, shown, or hidden. Void component resize component event C. Void component move component event C. Void component shown component event C. Void component hidden component event C. Container listener interface. These two have two methods when a component is added to container. Component added is invoked when a component is removed from the container. Component removed is invoked. Okay. Void component added container event C, and component removed container event C. Okay. Focus listener interface. This has two methods when a component obtains a keyboard focus. Focus gain is invoked. When component loses keyboard focus, focus loss is called. Void focus gain, focus event FE. Void focus loss, focus event FE. Item listener interface. Interface defines the item state change method that is invoked when the state of the item is changed. Method general form is void item state change item event IE. Okay. Key listener interface. This interface defines three methods. The key pressed and key release methods are invoked when a key is pressed and released respectively. Key type method is invoked when a character has been entered. Okay. If a user presses and releases the key, three events are generated: key pressed, type, released. If a user presses and releases the home key, key events are generated: key pressed and key released. Okay. So this way we have seen some new interesting topic related to event handling. Okay. In the next session, we will proceed further with a more interesting theory part related to event handling. Till then, you enjoy the process, you enjoy the event handling, you practice at your home. If you wish, create your own programs and build them unless and until I am creating the practical part for this. Okay. So meet you in the next session with the new topics. Thank you so much.